Hello and welcome back to the Tech Blackboard. This is our part 2 on DP-900 real exam questions. I hope you have already watched part 1 in this series. The link for the same is already available now in the I button on the top right corner and in the description box below. So let's start the part 2. In the first part, we looked upon questions that were of drag and drop style. In this part, I will take you through questions which are yes and no, or you can also say true and false. So in the first part, we covered question number 1 to 13, and in this part, we will start with question number 14. So let's begin. Our first question is, it has got three statements. The first statement says, normalization involves eliminating relationship between database table. In case of normalization, what we do is we build a lot of tables in a relational database, and amongst those table we set relationship so that we are able to secure or select the data from different tables. So normalization is essentially building the relationship between the database tables, which is quite the opposite of this one. So this statement is definitely no. So normalization is not about eliminating relationship, but it is more about building the relationship between the database tables. Let's check out the second statement. The second statement says normalizing a database reduces data redundancy. Well, if you understand the concept of normalization, in normalization we have various steps or stages, you can say. We have first normal form, we have second normal form, third normal form, and so on and so forth. Normally we put our data or keep our data in a practical scenario in third normal form. What is this normalization? So just to understand normalization process, we have, let's say I give you an example. You're building an application that store your daily sales transaction, right? So in this, what will you have? You will have information about the items you have sold. You will have its selling price, maybe your cost price, and you will probably also have the customer details who has bought this item, right? Now this will be a very big table with so many columns. On one side you will have so many so on one side you will have so many information about items, item name, item description, cost price, selling price, or whatever. Then you will also want to stay then you also would save customer details, customer name, customer id, customer address, phone number. But then this is a very tedious and redundant data, because with every transaction you are saving lot of customer detail which is unnecessary. So in a normalization process, what you will do is you will save only the transaction detail in one table, and the associated customer, let's say you will just put a customer id in the transaction table. Rest of the customer information will be taken to another table, that will be something like customer master. The customer master and this transaction table will be joined based on the customer id. So you're not repeating the entire information of customer, you are just storing customer id with each transaction. So then with this understanding, now if you will read this statement, normalizing a database reduces data redundancy. Definitely it's a true statement. So we are reducing the redundant data while we are doing normalization. Then the third statement says normalization. Then the third statement says normalization improves data integrity. Yes, definitely this is very soul of normalization process. This is done, normalization is definitely done with an eye or with the objective to maintain the data integrity. So this is a true or a yes. Now let's move on to our question number 15. Our question number 15 also has three statements. So now let's look at the first statement. Batch processing can output data to a file store. So, and then second statement is batch processing can output data to a relational database, and then batch processing can output data to a NoSQL database. So guys, we touched upon batch processing in our first part. So batch processing is basically when you process a lot of data in some chunks or batches. And if you look it from the context of Azure, then batch processing is a process which can output data to multiple data stores or data types or data targets, right? And when I say that, then batch processing can definitely output the data to a file store, relational database, and NoSQL. So all these statements are yes, right? So keep in mind, when batch processing essentially can output data in so many formats and into so many data targets, uh, and that's the reason that this all these statements are true. Okay, do not confuse batch processing with big data processing. So you might see on many sites that some of these options might be given as a no, which is wrong because they are confusing batch processing with big data processing. So there is a difference between batch processing and big data processing, right? Let's move to our question number 16. Our question number 16 is related to PaaS services. PaaS services means platform as a service. So let's look at the first statement. The first statement says PaaS data offerings in Azure requires less setup and configuration effort than infrastructure as a service or IaaS data offerings, database offerings. This is very true if you will understand the PaaS. So what is PaaS? PaaS is a platform as a service, as the acronym says. And the biggest difference between PaaS and IaaS is that in IaaS you actually start with building a virtual machine. However, and and on top of that virtual machine, you put your database, you configure everything, you patch your database, and just about every admin part that you would do in your normal data center, the on-premise data center, that you would also do in IaaS or infrastructure as a service. Whereas in PaaS, you would just configure data. So, for example, Azure SQL, you will just say while configuring on the Azure platform, you will just say, okay, I want Azure SQL database, and the underneath infrastructure, right? And the maintenance of the underneath infrastructure, you don't have to build any VM virtual machine. You don't have to go about installing operating system, supporting files, configuration files. You just do not have to do anything of that. Just select what you want to use, which type of database, and then that's it. Few questions here and there in the Azure portal, and then you're all set to use your database in a PaaS offering. So definitely PaaS actually requires a lot less setup and configuration effort than IaaS. So this statement is true or yes. Now let's move on to the second statement, which says PaaS data offering in Azure provide administrator with the ability to control and update operating version. See, if you will go to Azure portal and try to create or provision a PaaS database like a Azure SQL database, then nowhere in the process you will be asked to give or select the operating system, right? So that everything related to operating system installation configuration, that happens in the past. So that is actually taken care by the cloud service provider, so you don't have to worry about that. And that's the beauty of PaaS actually. So by this knowledge we can say that this statement is no, right? Moving on, all relational and non-relational platform as a service database offering in Azure can be paused to reduce cost. To understand this, I will give you a context of IaaS. Normally in infrastructure as a service where you build a virtual machine, you can actually go ahead and pause the virtual machine or stop the virtual machine, and that reduces your cost, because the moment you pause the machine or stop the machine, virtual machine, the cost is not happening now. You're not incurring any cost now. However, in PaaS, you cannot pause all the services to reduce the cost, right? The important thing is that it says all relational and non-relationals as a service, so you cannot pause all of them, right? So this means that this statement is again a no. Let's move on to our question number 17. Our question number 17 is again related to the PaaS. Okay, so as I told you before as well, PaaS data offerings. Um, okay, so PaaS data offering in Azure provides built-in high availability. Of course, as I mentioned before, that all the baseline admin work relies, or it is actually now with the cloud provider. So the availability or the high availability is actually the core or already built in the PaaS offerings. So you don't have to explicitly configure the high availability. It's already there, at least the base of it. So this statement is a yes. The second statement here says PaaS data offerings in Azure provides configurable scaling options. So this is also yes, because PaaS offering does provide you or enable you to configure the scaling option. So you already have some scalable options there, but you can go ahead and configure to suit your need, right? So this statement is also a yes. Then moving on, we have third statement which says PaaS data offering in Azure reduce the administrative overhead for managing the hardware. I think you can already now guess the answer of this, because I've already told you that PaaS is essentially the core essence of PaaS is to reduce your overhead of managing hardware, configuring, and all those stuff. So this is also a yes. Let's move to our question number 18. Question number 18 gives you a representation of a database design model. So in the previous slides or the previous videos, we have talked a lot about relational databases and questions related to relational databases. And I told you how relational databases are designed, how they are maintained in first or second or third normal form, and how they are well suited for transactional models or like OLTP application, which is online transactional processing. However, this question is little different and it's not related to OLTP or relational databases. So let's see the question. So in this question, you are presented with one schema and the information that is contained in the schema. You can see in the center of the schema there is sales. So basically it's recording the transactions of or the sales transaction for some company or some application, and you can see the other dimensions which are related to it. So you can see the customer information is being recorded, the product information, salesperson who was there to execute the sale, and then we also have the warehouse information. So now let's see the question. So the question asks you that what kind of data model it is. Okay, is it a transactional model? Is it a star schema? Or is it a snowflake schema? Right? And the second question asked is what is a customer? So is a customer the customer table here? You can see this. It has customer ID and there is no foreign key. So is it a fact? Is it a dimension? Or is it a bridge? Okay. Before actually asking, or sorry, before answering the question, I will show you what are these star schema and then snowflake schema. We have already seen the relational or the transaction model in the previous questions. Okay, let me take you through first the star schema and the snowflake. So if you see carefully, in the star schema we have a center of that schema. A center means the main thing that we want to record. So in this case, for example, we have sales in the center of the schema, and every other dimension is related to it, right? So you can see we have sales, and then we have the related bodies or the related parties, which are also known as dimensions, right? So this is how a star schema is modeled. So and you see it actually looks like a star. So you have this things and some spokes coming out in terms of this one, like you can see fact here, and then the spokes coming out, which actually looks like a star. So this is basically a star schema, right? And then what is the snowflake? So a snowflake, I would say, is an extension of star schema. So again, you have a fact table. Fact is normally a table which holds transaction, right? So sales transaction, so to say in this example, and same for the star schema. So sales transaction, a transactional table normally, right? And then similar to the star schema, we also have dimensions all related to the fact table, all around the fact table. However, the difference between star and snowflake is that in case of snowflake, you have other dimensions also attached to this main dimension. So you can say you have sub dimensions as well. So you have major dimension which are attached to the fact table, and then you have sub dimensions which are attached to the main dimension table. So for example, you have this time dimension. Now you can break the time in terms of months or year or decade or something like that, or time zones, or maybe you can segment the time, and that could be your sub dimension. So I hope you got an idea about star schema and snowflake schema. And now let's move back to our question. Our question asks what kind of model this is. So we can see we have a fact table in the center, and then we have dimensions all around. We do not have any sub dimensions in this diagram. So now I think you can already answer this question easily with that knowledge, that this model, the data model here is yes, I think you already guessed it with me. This is star schema. Okay, now let's see what is the customer. I already told you we have a fact in the center and dimensions on the outer part. So thus the customer is a dimension here, and that's the right answer. Okay, I hope this question has given you some idea about star schema and snowflake schema. Go ahead and read about these schemas, because these are major design models when it comes to design a data warehouse style of a database, or sometimes you also call them OLAP. So this is little different from OLTP, which are more transactional based, and this is more suited for analysis or analytics. So sort of a data warehouse. Now let's start with our question number 19. Our question number 19 says a key value data store is optimized for, you have to choose between enforcing constraints, simple lookups, table joins, or transaction. So key value pairs are nothing but the data is actually stored in terms of key, and there is a value for each key. So these are very simple data lookup tables, and they are very optimized for simple lookup kind of thing. Just to before I actually pinpoint the real answer, I will give you uh, uh, So our first question is key value data store is optimized for, and then you have to choose between enforcing constraint, simple lookups, table joins, and transaction. Okay, before I answer this question, I will take you to a Microsoft page where we try to find out the correct answer for this question. In this page, I will provide the link anyways in the description box below, so you don't have to worry about the link. So coming on to this page, just scroll down here, and then you can see there is some information given about key value pair, and you can already see how a key value pair data store looks like. You have some keys and you have some values for each key. Okay, just coming, if you will read through this context that is given for key value pair, then you can easily see that here it says that, yes, here, so it says key value stores are highly optimized for application performing simple lookups, right? So this is a support for our answer, and this gives a clear understanding, and you are not confused between different answer that might be available on different websites. So this is then a sure short answer that they are optimized for performing simple lookups. Thus our correct answer is simple lookups. Okay, moving on to our question number 20. Our question number 20 says that relational data uses dash to enforce relationship between different keys, different tables. We have already talked about this relational database in our previous slides and previous videos. So relational database, how do they maintain data? They maintain data in terms of tables. There are a lot of tables. So for example, let's say you have a table about an employee, and there is a table about department. So let's say employee works in HR department. So how do you maintain a relationship between both these tables? So the relationship between the tables are actually maintained by keys. It's not collection, it's not columns or partition, but it's keys. So normally, just to elaborate here, we have a concept of foreign keys and primary keys. So let's say in our previous example, we would have a employee table, and in employee table we would store department ID, which would be a foreign key, and this department ID would be a primary key in the department table. So this is how you join different tables to fetch the desired information. I hope this is clear to you now. Okay, moving on to question number 21. Now we have, so in this question we have given some options on the left hand side. It says index, view and table, and here are some blank boxes. So what you actually need to do in these kind of question is you need to drag and drop the correct option in these blank boxes. Okay, so in this is the way you will be presented in the actual exam, right? But this, because this is a slide, so we are not able to achieve that functionality. Okay, but anyways, you understand that. So the options given are a database object that holds the data. Second option is a database object whose content is defined by a query. Third option is a database object that helps improve speed of data retrieval. If you have ever worked with these kind of with data, you would already know the a database object that actually holds the data. In fact, I mentioned in this our question number 20 also. So the data object that holds the data is actually a table. So in a relational database, all the data is held in a table, right? There are a lot of tables that you can build, and everything is stored in terms of tables. So it's more like if you have seen an Excel file, how it stores the data in terms of rows and columns. This is very similar to how you can visualize a table in a database. So the answer for this one is table. Then a database object whose content is defined by a query, right? So let's say you have a table, a big table, and then you have a customer who wants to see the data, but you don't want to give him access to the entire data set. Then what do you do? So normally what we do, we build views, right, on top of the tables, and the views are defined by a customized query, right? So you just, let's say you just want to show the employee name, employee ID and his department. You don't want to show his address or phone number, maybe it's under GDPR. So what will you do? You will build a view on top of a table, and then give access to the client who wants to use it or who wants to see the data. So view is a database object whose content is defined by a query. So the correct answer is view. And then we are actually left with the with just one index. So of course index is the correct answer for the third one, a database object that improves the speed of data retrieval. However, just to give the understanding, I will tell you indexes are let's take the example of SQL. So in SQL we have the famous type of indexes are like clustered index and non-clustered index. So what will an index do? So let's take the analogy of a book. So when you have a big fat book and you want to see or want to find the information in a book, what do you do normally? You browse through or the you shuffle through the index, and then you can find, okay, this information is in this page. This is very close to what indexes do, although there is a lot happening under the hoods, but you can visualize the index database index similar to this one. So indexes are a database object that facilitates faster retrieval of the data, right? I hope you understand that. Okay, moving on, we have question number 22. So question number 22 again is a drag and drop kind of question. So you have given some options here and you have to drag them onto these data type boxes to match these options given here. So let's read out. So our answer area is given Azure Blob Storage, Azure Cosmos DB, Gremlin API, and then we are given Azure Table Storage. So now you have to tell which is the best suited. So what is best blob storage? I mean, what are you gonna store in a blob storage? Are you gonna store image file? Are you gonna store key value pair or relationship between employees? So the correct answer, see, blob is what? Blob is an object, sort of. If you already know the data types, then blob is a data type which stores another objects, right? And thus, if you take that understanding and try to see the options now, you will already see that image files are the best suited for blob. Not only image file, you can store your video files, you can store your audio files, so pictures, images. So these are the object for which blob storage is the best, right? Okay, moving on, we have Azure Cosmos DB, Gremlin API, and what is this best suited for? Okay, so either it's key value pair or relationship between employees. So it is the correct answer is relationship between employees. But just to give you prove the context, prove the correctness of this answer, I will take you again to the Microsoft site, same page, and if you just scroll down a little bit more, you can read about data document database, but this is not what we are looking for. We are looking for graph database. So you can see here, this is a graph database. So what is a graph database? Graph database actually facilitate you to store relationship between the objects. You can see this is an employee, his department, and then another employee department. So this is what graph database is. Coming back to our slide, Azure Cosmos DB Gremlin API is one of the best known API which we use normally with these kind of graph database. So this is our correct answer, graph database which stores relationship between employees. Then the third obvious answer we are left with is Azure key value pairs. We already talked about this one here in question number 19. So key value pairs are best suited to be stored in Azure table storage. Moving on, we have question number 23. By default, each Azure SQL database is protected by what? Is it a network security group? Is it a server level firewall? Is it a Azure firewall, or is it a Azure front door? So the answer to this question is Azure firewall, right? Okay, then moving on with the question number 24. the massively parallel processing MPP engine of Azure Synapse Analytics. How does it do the massive parallel processing? That's the crux of that is what the question wants to ask you. Does it distributes the processing across compute nodes, or it distribute processing across control nodes, or it redirects connection across compute nodes, or redirects client connection across control nodes? If you look at this question, see, last two options are not very relevant because it's talking about redirecting the client connection, so it has nothing to do with, actually not related to this parallel processing. Now, the coming to the first two options, we have either it distributes processing across compute nodes, or it distribute processing across control node. See, control nodes are more, they control the processing. So whenever something is coming for processing, so control nodes are the nodes which are deciding which compute nodes will actually process this. So they are more of a controller, right? So the correct answer for this question is actually distributes processing across compute nodes. And if you see, actually compute is the keyword here, you see. So it's the compute nodes which actually compute, right? So you already know that the processing is done actually on the compute node. So this is our correct answer. Now let's look at our question number 25th. It asks, relational data uses dash to enforce relationship between different tables. We have already discussed in our previous slides, and I think you can already guess the answer. The answer to this question is keys. So we have foreign keys and primary key concept with which we maintain relationship between different tables. Jumping on very quickly to our question number 26, we have creating closed caption for audio files is an example of dash analytics. So you have to tell what sort of analytics is creating closed caption text for audio files. So we have already seen in our previous slides, there can be few variations of this question that may come in the exam. One is this, of course, that you can see on your screen. The second one, they can also put the question like transcribing audio files. So that can be also one of the variation of the question, or they can also say creating text for audio files. So both two, three variations, both can come in your exams. So, but the answer for the same is, as we have discussed in our previous slide, is cognitive analytics. I will encourage you to see my previous videos in this series, like part 1, because in that I have in detail explained why the answer for this is cognitive analytics. And as I already mentioned at the start of this series, we are repeating the question to enforce the understanding in you, so that you don't make mistakes with the variations of questions that are expected to come in Microsoft DP-900 exam. Okay, with that, let's move to our question number 27th. Question number 27 asks that you have to identify the object that is associated with the table that sorts and stores the data rows in the table based on their key values. So if you see my previous videos, I have already hinted you that there are two major type of indexes when we talk about database like SQL servers. The first one is cluster index, the second one is non-cluster. Cluster index is basically an index that actually stores the information or the data inside the table um, depending upon the column on which that cluster index is created. Okay, so that's why uh, cluster index is that object which actually stores the data and sorts the data, the actual rows of data based on the columns on which it is created. So other three options are not valid. The correct answer is a cluster index. Jumping on to the question number 28, transparent data encryption encrypts what? Does it encrypts a column to protect data at rest and in transit, queries and their results in order to protect data in transit? The third option is the database to protect data at rest, or the fourth option is the server to protect data at rest. So if you read about transparent data encryption on Microsoft site, you would know that it doesn't protect the data. It doesn't encrypt a column to protect the data at rest. It is not also related to the queries and their results. So the third option is the database to protect database at rest. Yes, so this option actually is very close to what TDE does. But let's look at the fourth option as well. The fourth option says the server to protect data at rest. So basically, you see, TDE is actually related to data at rest. Okay. However, it protects the database. So it doesn't protect the server itself, it protects the database. Thus, the correct answer for this is the database to protect data at rest. Okay. With this, let's move on to our question number 29. Our question number 29 is a drag and drop sort of question. You have to drag or match these components with these statements. So let's look at the first statement, which is prevent access to an Azure SQL database from another network. So let's see the options. We have authentication, we have firewall, we have encryption. Now you see, when you design a network, right, in order to protect a normal network, what do you should do? You normally build a firewall on top of your network to protect the network from the outside network. Similarly, when you create a database inside your network or VPN, then you create a firewall to protect that from an outside network. So the correct option for the first statement is firewall. Moving on to the second statement, we have support Azure Active Directory or Azure AD sign-ins to an Azure SQL database. So in this case, you would do what? So what you are doing is essentially all the sign-ins that are coming to your SQL database, you are validating those sign-ins. So this process of validating the sign-ins to your Azure SQL database is called authentication. Okay, so now let's move with the third statement. Ensure the sensitive data never appear as a plain text. So of course, this is encryption. So encryption is actually associated with these kind of things where you don't want to show the real data. You encrypt the data and then that encrypted data is used, right? So let's move on to our question number 30. Our question number 30 is also a drag and drop kind of question. However, it's an interesting question because in this you would see that you only have two options given here. However, here you have three statements given. So this means that one of these options will be repeated or it comes two times. Let's see. Okay, so the first statement says data for a product catalog will be loaded every 12 hours to a data warehouse. So now if you see, I already told and explained in my previous videos as well, but just to give a very quick reference again. So batch data is something that you process in a batch or big loads or big chunks. That's batch data. Streaming or online or on-time processing is basically as and when the data comes, you process the data. So that's the basic difference between batch and streaming data. So now you see, when you read this, it says that you will be data for a product catalog will be loaded every 12 hours. So see, you are collecting the data, you're letting the data come in, and then every 12 hours you're gonna process the data. This definitely, as I mentioned, is an example of batch load. Okay, now the second statement says thousands of data sets per second. This is very important. See the keywords here. Okay, so we are saying per second. So as in when the data is coming, that picture should already be creating in your mind when you're answering these kind of questions. So per second for online purchase will be loaded into a data warehouse real time. Do you see this word real time? When real time is there, you don't even need to think of any other option. It's definitely streaming. So it's a streaming is the correct option here. In Microsoft exam, they can give, instead of streaming here, they can also use the word on real time processing or on time processing, right? So you don't have to get confused with different terminologies. Just build your concepts well so that you're never making mistake in these kind of questions. Okay, then the third statement says updates to inventory data to be loaded to a data warehouse every 1 million transaction. Says every 1 million transaction. So what are you essentially doing is you are processing 1 million transaction in a batch, in a chunk, and that's why the correct answer for this is batch processing. With this, we sum up our part 2 on DP-900 real exam questions. Stay tuned to the channel for part 3 with more interesting questions coming up. If this video has added any value in your learning, a like and subscribe is highly appreciated. Share this video in your family and friends to spread and expand their learning. Your comments and feedback give me a chance to interact with you, and I look forward for them. We will meet again in our next video. Till then, stay fit, keep learning, and thanks for watching.